On February 10, 2023, NASA's Solar Dynamics Observatory took some pictures that shocked the scientific community. They show the sun's surface and deep interior from just 10,000 miles away. That's closer than Mercury's orbit, the planet closest to the sun. NASA shared these images online and they went viral. Scientists couldn't believe what they saw because the quality was so much better than expected. It even revealed 3 worrying things about our star. But first, let's go over this mission in detail. The Solar Dynamics Observatory was launched into space on February 11, 2010. NASA worked together with the European Space Agency, also known as ESA, to send this spacecraft to orbit. Its main job is to take pictures and videos of the sun, especially its corona. The corona is the sun's outermost layer, which is usually hard to see because it's very far away. Our Earth is around 94 million miles away from the sun, so seeing details on the sun's surface is challenging. But that's exactly what makes this mission so incredible. Using a special camera, the observatory takes pictures in ultraviolet wavelength, which helps it capture things related to the sun's weather, like solar flares and coronal mass ejections. After the spacecraft reached its orbit, it sent back amazing close-up views of the sun's corona for the first time. These observations have taught us a lot about how the corona works. One of the cool things the SDO found is something called coronal rain. Coronal rain happens when the sun's magnetic field lines get all twisted up and release a bunch of hot plasma. Think of it like a giant explosion on the sun's surface. This plasma shoots out into space at super high speeds. But then, as it moves away from the sun, it cools down and slows down too. When it reaches the outer part of the corona, it starts to fall back towards the sun like rain. But instead of water, it's this stuff called molten plasma. It looks like a waterfall of glowing gas falling on the sun. This coronal rain is important because it's part of a bigger process. See, the corona is full of charged plasma particles, and those particles interact with the sun's magnetic field lines. This creates a bunch of energy and causes these powerful solar flares that shoot out into space. These flares can be really dangerous because they carry a lot of energy. As they head out into the solar system, they sometimes hit Earth and can mess with our stuff. For example, they can mess with our telecommunications or harm astronauts in space. That's why it's so important for us to understand what's happening up there. And thanks to the Solar Dynamics Observatory, we've learned a lot about the sun and its stormy weather. The observatory has been taking amazing pictures and videos of our star for over 10 years now. And one of the most mind-blowing things it's shown us is something called coronal rain. We're still learning about this, but we think it's part of a big cycle that happens on the sun. The sun's magnetic field lines go through a lot during this cycle. They get twisted up and tangled and then release a bunch of energy. That energy comes out as light and plasma, which is a hot gas-like substance. This creates a bright flash on the sun's surface, which we call a solar flare. The plasma in these flares can reach temperatures of over 100,000 degrees Fahrenheit, which is 10 times hotter than the surface of the sun. These flares can be huge, covering a big chunk of the sun's surface, and when they happen, they send out a burst of radiation and magnetic fields into space. But here's the thing, not all solar flares are the same. Some are small and don't really do much, but others can be big enough to affect our life here on Earth. For example, they can mess with our telecommunications or harm astronauts working in space. That's why it's important for us to keep an eye on the sun and try to understand what's going on with these solar flares. The Solar Dynamics Observatory has been doing just that since it started taking amazing pictures of the sun back in 2010. It's helping us learn more about the sun and protect ourselves from its powerful flares. Now let's move on to another mind-blowing thing the SDO found, the grass-like structures on the sun. These mysterious structures look like tall grass waving in the wind, and they're actually pretty big. They're larger than Mount Everest and pop up every 5 minutes on the sun's surface. But what's really happening up there? Well, it all has to do with the sun's equator. It rotates faster than its poles, which creates a bunch of twists in the sun's magnetic field. Think of it like a rubber band that's been stretched and twisted. When the rubber band snaps, it releases a lot of energy. Well, something similar happens on the sun. The twisted magnetic field lines eventually snap and release a shock wave. This shock wave blasts outward from the sun at speeds 60 times faster than the speed of sound. As the shock wave moves across the sun's surface, it creates these tall, spiky structures that look like grass. These structures are actually loops of magnetic field lines that have been pushed up and twisted up by the shock wave. They're not real grass, of course, but they sure do look like it. These grass-like structures are a pretty new discovery. Scientists only spotted them for the first time in 2012, thanks to the Solar Dynamics Observatory. Before that, we had no idea these structures even existed on the Sun. Now let's talk about the third amazing thing the SDO found on the Sun: its surface cracks. To understand what these cracks are, we need to take a closer look at the Sun's surface. The Sun isn't smooth and flat like a pancake. Instead, it's rough and grainy looking. These rough patches are called solar granules, and they're kind of like bubbles on the surface of a boiling pot of water. Each granule is about 50,000 miles across, which is as wide as 20 American states lined up side by side. They emerge from the churning plasma below the Sun's surface and live for around 10 minutes before they pop and merge with their neighbors. But the cracks aren't in the granules themselves. They're in the thin layer of the Sun's atmosphere that sits above the granules. This layer is called the photosphere, and it's where the light we see from the Sun comes from. The cracks themselves are boundaries between the different granules. They're not cracks in the traditional sense. They're just places where the hot plasma from the Sun's core is rising up to replace the cooler plasma that's sinking down. These cracks can be hundreds of miles long, and they move around the Sun's surface like conveyor belts. Now, why is this important? Well, understanding what's happening on the Sun's surface can help us predict what's happening in its atmosphere. And that's important because the Sun's atmosphere can sometimes mess with our stuff here on Earth. For example, the solar flares and coronal mass ejections that happen in the Sun's atmosphere can disrupt our communications and power grid systems. By studying the Sun's surface, we can hopefully get better at predicting when these disruptive events will happen so we can protect ourselves. Overall, the images captured by the SDO are just incredible. They show the Sun in ways we've never seen it before and help us understand our star like never before. Why do these observations matter? Solar activities like flares can disrupt Earth's technology. For example, in 2022, 49 of Elon Musk's Starlink satellites were destroyed by solar flares. In 2023, a solar flare equivalent to 1 billion hydrogen bombs caused a communication blackout in North America. Since 1580, 33 solar flares have caused significant technological damage on Earth. NASA and ESA study the Sun to predict solar flare impacts more accurately and mitigate future damage. There's also a scientific concern. Even though these phenomena are normal for the Sun, they are concerning because of their potential to disrupt Earth's technology. Despite this, in the last 20 years, space agencies have launched 10 solar missions. Why are they keeping it a secret? Or is there something else driving their interest in the Sun? Historic achievement. The photosphere images are the deepest ever taken of the Sun. Ironically, the Sun's smooth surface seen during sunrise and sunset is the photosphere. We see it every day from Earth, but these pictures show it in unprecedented detail. The Solar Dynamics Observatory has given us a front-row seat to the Sun's dramatic activities and reminded us of the awesome power of our universe. From the scorching hot plasma of the corona to the grass-like structures in the chromosphere and the rough surface of the photosphere, the Sun is a truly fascinating object. Thanks to this mission, we are better equipped to understand and predict the Sun's behavior and keep an eye on its potentially harmful activities. Who knows what other amazing discoveries await us as we continue to explore our nearest star? Now it's time to hear from you. What do you think about these mind-blowing pictures of our Sun? Leave your thoughts in the comments below. And if you enjoyed this video, don't forget to hit the like button and subscribe for more updates on space exploration and scientific discoveries. Thanks for watching, and I'll see you next time.